So, is my interview is ready?
Yes, Kranthi.
Yeah, introduce yourself.
So my name is Aditya, and I'm actually interviewing for some of the companies here. Been in the software industry for about 3 to 5 years, I'd like to say. I worked in various sectors and currently working in building APIs for Microsoft Azure and IBM Cloud. That's a very brief background from my side, Kranthi.
Okay. So you worked on Microsoft API. So have you feel any proud moment in your project, in your
Yeah,
work
so
time?
correct. So I work closely with Microsoft Azure, and one of the APIs that I kind of developed is being integrated in the platform, and it's being earning pretty good revenue of about somewhere around $1 million per year. And I feel proud because I was given an opportunity to write the public and internal APIs for this product, and that in turn helped in generating a lot of revenue for our company. And also it gave me an opportunity to understand more on the implementation side of the RESTful APIs, and also learn more about the distributed systems.
Okay. So which program you prefer to code?
So I'm currently using Python for the interviews, Kranthi.
Okay. So what is the scaling of your language up to 10?
So I'd like to say somewhere around like 6 to 6.5 for Python.
Okay. Okay. So let's jump into the code.
Okay.
So So the question is that have you heard about graphs?
Okay. Yes.
So so have you familiar with depth first search traversing of a graph?
Sure.
So today query is that
Sorry.
given graph. So I'm typing the question.
Okay.
So given graph, find topological sort.
Okay.
So for example, so 5 to 0
Okay.
as well as um, 5 to 2, then after um, 4 to 0 and 4 to 1, 2 to 3 and 3 to 1.
Okay.
So the graph is given and the expected output is 5, 4, 2, 3, 1, 0.
Okay. So essentially the order of this, right? So, so Kranti, one question is like, whatever the input you are giving me, right, 5 to 0. So I'm assuming 5 is the index, sorry, the node, correct? And that is connected to 0.
Yes,
Am I right? So
yeah, clear.
index 5, which is connected to index 0. So I'm just writing something on my notepad. So 5 is also connected to 2, and we have 4, which is also connected to 0, and we have 4, which is also going to 1, and 2 is getting connected to 3, and 3 is coming to 1, right? So with the topological sorting, if I understand, like the way how I think is, for any graph we have edges, incoming edges and outgoing edges, correct? So for any
Correct.
node, if there are no incoming edges, that means there is no any some sort of like a dependency on that particular node, correct? So here, what it in the given example, 5 is dependent, is kind of a dependency for both node 0 and 2. So if we want to traverse 0 and 2, first we should traverse 5, or we should process 5. Then we have to go for 0, or then we can go for 2, correct? So what it means is we will be selecting the nodes which have 0 incoming paths, right? Or like 0
Yes.
incoming edges. So that's the one thing. So in this case, the one possible answer is 5, 4, 2, 3, 1, 0, and it's one more is 5, 4, 0, 2, 3, 1, 0. 1, yeah, 1, 0. So I think that there could be multiple solutions. So you are interested in any one of those solutions, right?
Yes.
Okay. So with this in mind, the way how I want to approach this problem, Kranthi, is I'd like to calculate the edges which are having no incoming edges. Sorry, I want to calculate the nodes which don't have any incoming edges, right? And once I have such nodes, I'll put them in some sort of like a queue, and I'll start processing each one of them. And every time I remove something from the queue, I will see if they have any child, or if they have any where we can say that, for instance, in this, right, 5 is connected to 0 and 2. So I will see when I'm processing node 5, I will get what are the children of 5. In this case, it's 0 and 2, right? So I'll pop them, and I'll see if there's any incoming degree or incoming edges. If there are no incoming edges, then I put it back them into the queue. So I kind of process them one after the other, and at the end, I'll have a list or an order that will mention me what will be the topological ordering. So I'm kind of using here a queue as a data structure, and I'm kind of traversing in one level after the other level. So in that case, my complexity would be like, if I'm right, it would be O of n, because we are traversing each node one, and also the space complexity is we are storing it in some sort of like a queue data structure. In the worst case, it would be again O of n. So with that details, I'd like to proceed further. If there are no any other questions.
So Aditya, tell me one thing, that the given graph, how you represent?
So I'm kind of presenting the given graph as an adjacency list, right? So for a
Okay.
particular node, we have a list of children or list of neighbors we can call. So I'm thinking of in that direction.
Well, pretty good. Okay,
Uh,
so can you do it? Can you code it?
yeah, sure, definitely. So let me start. So
Yeah.
I'm using Python, so I'll walk you across. If the syntax is not clear, just let me know. So how I'm considering is topological sorting. I have a self parameter right now. So what I want is I want let me assume that we are giving me as input as a list, correct? Which will be having all this 5052 as a mappings, right? So first thing what I'll do is I'll check if the input is empty, right? If the input is empty, I'll just raise an exception so that any person or a client who is using this topological sorting as an API, they will get an okay. So if nothing is there, if it is a valid input, I'll just start processing. Order is equal to a list, so I'm considering it to be a list for now. Now what I'll do is I'll first consider in degree map, correct? So in degree map, what I'm doing here is for each edge, I'm saying what are the number of in degrees for that particular node, right? So that is the data structure that I'm using here. Currently, what I'm saying is X would be my node, which will be having 0 in degrees, and this is for each node in the graph, right? So I'll say for each X in range of input. So I think input, it's kind of a parameter here. So let's say input nodes. think if I'm right, it's kind of taking it as a standard keyword. So I'll just make it as keyword. So this is where I'm constructing my integrity, and this is where I'm constructing a graph. So my graph, as I told, is it's an HSC list. So what I'll do is X is my node. It has list, which is an empty list right now for each node in the input nodes. Correct. So I just constructed two of my data structures, in degree map and also the graph. Now I will just like build the graph. So in building the graph, what I'll do is I'll traverse each of your inputs, right? So what I'll say is for node in input nodes, correct? What I'll say is um, just for simplicity purpose, I'm not using these arrow marks. I'm considering this to be a tuple. So what I'll say is my parent is nothing but first part of the node, that is node 0, and my child would be node 1, right? This would be the kind of bifurcation. So for example, here in one of your inputs, I'd like to consider 5, 0 as my input, right? So if in 5, 0, my parent would be 5 and child would be 0, correct? So that is the one thing. So what I'll do is now I need to add this to the graph, right? So I'll say for graph for this particular node parent dot append this child. So I'm appending that, and what I'll say is in degree map. That means this particular node has this particular child node has a parent, right? So it means its in degree map or in degree data structure should be updated, correct? So what I'll do is in degree map of child should be incremented. This is just a simple building of graph for all of them, correct? Now what I'll do is I need to process them, right, Kranthi? So I need to find out the nodes which are not having any incoming edges. So to do that, what I'll do is I'll consider queue. So I will use something called as a deck in Python because of its pretty good time complexity. So let me import that. So this should be my sources, right? Or source nodes which are having 0 integrity. So I need to iterate over all of them. How do I iterate it? I iterate it based on the integrity map. So dot items. So everything from that map, I'm going to remove it. Correct. And what I do is, I think, yeah, even map is fine. So I'll pop each of this item, correct? So when I pop each of this item, I will check if my in degree map is 0, right? So if for this particular, if it is 0, that means it's a source node, or it has no dependency, or it has no incoming edges. So what I'll do is I'll say sources dot append, and I will add that node, correct? At the end of this loop, what I should having is the list of all the nodes which are having zero integrities, right? Means they don't have any dependency. Now this is where I'll start traversing the actual graph. So what I'll do is I will traverse this queue until it's completely empty. So I'll pop an item, or pop node is equal to sources dot pop left. In Python, we pop it from the left. There is a method which will help us to remove a node from the first. I pop this item, and this is the item that will become part of my result set, right? So I'll say topological order dot append. I will add this node, correct? Once I add this node, I need to check if it has any children's, right? So I'll say for child in pop node dot children, or yeah. So the children will be put part of a graph, right? So I'll say graph of this particular pop node. For each of this child, if it's in degree of this child equal to 0, then it will become sources dot. So I'll add it back to the queue child, right? So at the end, what I should be having is I should be having logical order that should give me the result. So what I'm doing here is I'm iterating over the queue. I popped a node, I appended. Okay, and here what I should do is, okay, so when I check it, I should actually in degree map of this child should be made -1, because if there are two nodes, I want to decrement that and then check. So I decremented that, and in degree map of child, if it is 0, that means it has no incoming nodes. So sources.append is a child. So this will give me a topological ordering. So let me take some quick dry run. Topological sorting, tux of input or something like that, and then we construct an in-degree map where every node has a value, and that value corresponds to number of in degrees for that particular node. I'm constructing that data structure and then constructing a graph as an adjacency list, and then I'm processing each of the input in this given inputs, and I'll adding it to the graph, and I'm incrementing the in degree map for each of the child, and this is my queue, and then I start traversing the queue. Sorry, I start traversing the graph to see if there is a node that has 0 in degrees, and I'll append it to the queue, and I'll traverse that queue to get the item from. Yeah, it looks like this works. Let me take an example, Kranthi, okay? So let me take the example as a list consisting of a list. So as I told, like I'm not using arrows just for simplicity purpose. So I'll use 5, 2, 4, 0, 4, 1, 4, 3, 3, 1. Correct, right? So the input is a valid input, so we are not going to raise an exception. The topological sorting is currently an empty. Now I'll construct this in degree map, right? So my in degree map would look something like this. So it's essentially a dictionary or a hash map, right? So how will it look like is, oh, sorry. How will it look like is for each node, right? In the input node. So here the input node is for X in range of this inputs, correct? Yeah, I think I made a mistake here. So what I need to do is I should say number of nodes is equal to length of input nodes, because you are giving me a length, right? So I should say instead of that, I should do here. Otherwise, it will be difficult to keep track of it, right? So number of nodes. So what I'll do is my first X, I will say everything. So how many nodes are there? 1, 2, 3, 4, 5, 6. So yeah, actually in this case, the number of nodes, it starts with 0. Let me refer my notes. So it's 1, 2, 3, 4, 5, 6, right? So the nodes is 6, correct? So I'll be having 6 of these entries here, each with x, 0, 1, etc., right? So and so. I'll just put this out. And then we similarly have a graph. And this graph is kind of an adjacency list. It will have a kind of like a node, and then its list of children, node 1, and then followed by node 2, correct, and then etc. So now let's start processing, right? So for node in input nodes, so in this first case, I'm getting. Let me copy this input here. You are with me, Kranthi, here? I'm not hearing anything. Hello?
here only. I'm here only.
Okay. Okay. And okay. So okay. So when I'm traversing it, one thing I just kind of assumed here is I believe that there are no cycles here. Uh, yeah, so if there is a cycle, then this will not work, and I can actually show you some examples there. But let's do a dry run here, right? So in this case,
Yeah.
my parent node is 5 and child node is 0, correct? So I'm kind of and what I'll do here is I'll construct my graph. So my graph will essentially be a list. So what I'll do is for parent 5, I will construct a list and put 0 as a child, correct? And that will be my graph. And my in degree would be essentially of a child, right? So what is the child here? The child is 0 and its count is incremented to as 1, right? So that is how the graph is constructed. Now it go to the next one. Now next item is 5 comma 2. So the parent is 5 and the child is 2. So here 0 comma 2 gets created, and then here 2 comma 1, that's an in degree, and then 4 comma 0, 4 comma 0. So here what will happen is 4 will be created, and then there is a uh, empty list, and here 1 will be having a count of 1, that is it just keeps a track of how many in degrees it's having. Then next is 2 comma 3, 2, and it's 3, right? So here 2, its child is 3, and here 3, its count is 1, and next is 3 comma 1. So this is 1, this is 3, right? So here 3 will be having child as 1, and 3 colon 1, that means 1 is having 2 incoming edges, right? So that will be 3. So let me check with my graph what I have here. So 2 has 1, right? 0 has 1, correct? And 1 has 2 incoming edges. 3 has only 1 incoming edges. And 5, yeah, it's not there, so that is there. And 0 by default. That's fine, that's taken care of. Now I initialize my queue here, and then I start iterating my in degree map. So I will just copy paste this here. Right now, this in degree map, my node length is 0, right? So which is the first one that will be having a node length of 0. So in this case, I think 5 is 0, 0,24. So I think I should be checking node in the graph and then check the corresponding item there. So I think should I be making that change? Not really. What I would like to say is if the in degree of that 0, right? So here I'm taking in degree map. So 0 comes here. So I have only 5. It's not here. 4 is not here. These are the two things that will be part of my node already, because I'm populating all of them to 0 here on line where it went on line 22, right? So they will be part of this already. So here it comes. So first, which are the two nodes that are having 0 degrees is 5 and 4, right? So 5 and 4 will be appended to my queue, correct? Now I will start popping from my item. So I'm having 5 comma 4 in my queue. So let's say that I'm popping 5 now, correct? And I make that to be a part of my result set, correct? And what I'll do is I will check if it has any child, right? So here 5 has 2 children, right? 0 comma 2. So these 0 comma 2 will come here on line 57. Now each of their in degrees map will be reduced to 1. So I will go to my in degree map here. Now let me copy paste this here. Correct. So zeros will be decremented to 0 and 2 will be incremented also by 1. So they both become 0, right? Now both, like I will check if it becomes 0, right? If it has become 0, I will add them to the queue. So I have removed 5 from my queue, 4 is there. I'm on line 54. So I'm adding 0 now, and then I'm adding 2 to the queue. Correct. Now I will start processing again. So this time I will pop 4. So I will remove 4 from my queue.
So, Aditya?
Yeah. Yeah.
Aditya?
Yeah. Can you hear me? Is anyone able to hear me?
Yes, we can.
Aditya?
Yeah. We can hear you, Aditya. I think actually Kranthi, I think maybe try to say again.
Hey, Kranthi, I can hear you. Can you hear me? Hello?
Hey, you're audible.
Kranthi, I think you're muted. Actually, I'm pausing the recording.
So Kranthi, I saw your line to say run and show the output,
Yes.
right?
Yeah.
So
Yes.
you take the input. Okay. Why is it at the same time? Okay. So I'm just doing a dry run. So let me try to run it. Okay. Okay, I got it. 450. Yeah, I took the fourth one. The one which, so 4. I'm using my graph on my book. So 4, then 5, then 0, 2, 3, 1. Yeah. So Kranthi, you're there.
Are you sure? So
So
the expected output is. Okay, are you sure that 0 is coming before 2? Hello?
Yeah, so here, right? So 5, 0, 5, 2, 4, 0. So 0 and 2 both are having incoming edges from 5, right? So as soon as 5 gets processed, they both have equal chances, right? 0 or 2. So yeah, I think it's right.
Are you sure?
So 5, 0.
Aditya?
Yeah, I'm checking. I'm checking if it is having anything wrong here. So 5, 0. I'm checking the input, right? So why does it have 0, which is processed last in your example, right? So 0 comes, as soon as 4 and 5 gets processed, we can take 0, right? So that is one. And in degree, my parent is 502. 4 is not having anything. So 2 is having incoming edge as 3. And 3 has incoming edge as 0. And yeah, 0 has its incoming edge as 5. No. Okay. Yeah, that's okay. So, yeah, Kranthi, for me it looks right? Because these are the edges, which is a parent, right? Or the some kind of like a first that has to be processed, then only the next item will be processed, right? So, um, in the graph that I have kind of drawn here, so this is how my graph looks like, right? So here I have y, which has 0, and then
Mm.
y also has 2, correct? Uh, and then I have here 4,
Mm.
which has an incoming edges to again 0, right? So it's
Mm.
difficult to draw here, but let me try.
Aditya, you can actually draw. There's a button in the bottom if you want to draw.
Oh yeah, okay.
Yeah.
Good, that's good. So here I have look. What's this? So here is my 5. Here is 4, right?
Mm.
Correct. And then
Yeah.
here we
Okay.
have 0, right? And 5
Mm.
is having this has 0 has like dependency on 5. 4 is also having dependency. 0 is also dependency of 4, right? And
Mm.
then 5 also has 2, correct? And then
Okay.
2 has 3, right? And then
Mm.
after
Yes.
3, it's 1, correct? And
Yes.
4 is again having dependency, right? So first what I processed is 5 because it has 0 integrate. So I can either process 5 or 4. So the output that I showed you processed 4, right? So I'm kind of removing
Okay.
4 completely, right? Now
Mm.
both 5 and 0 have equal chances, and 1, right? Both have, all three of them have 0 incoming. So it can process either of them. So in this case, the code processed 5. So I'm removing 5 as well. Next comes 0 and 2, right? So 0 and 2 and 1, three of them can be processed. So in this case, I think it processed 2 or 0. I don't remember. Let me see what output it gave. It processed 0, right? So I removed 0 from the list as well. Then what remaining is 2, 3, 1, right? So I can process 2 first or 1 first. In this case, I think it was processed as 2, right? Because that was put in the queue first. So 2 get processed and then 3, 1. So 3 gets processed later. So it was in the earlier part of the queue, and then finally 1. Yeah, then finally it was 1. So if you look at it, this gives a topological order. So this is one of the possible solutions, right? I think uh, topological sorting has like not one unique answer. And if there is any cycle, then this particular part of the loop, right, where I'm kind of popping from the queue, will not even work properly, right? It will be in this infinite uh, loop. It keeps on because the incoming edges will be always there. Kranthi, are there?
Yeah, I'm here only. But can you explain what exactly means by topological sort?
So the topological sort here essentially means, right? Let's take an example, right? So if you want to
Mhm.
process some work and if you have some dependency on that, right? So the node which is having dependency should be processed first, correct? So just to give an example, like if you're having a list of tasks to process, correct? So after task one, we have to do task two, correct? So in that case, we should not do task two first. We should be doing task one. Once that is completely processed, then we can start the task two. So this particular order, which will tell me in which order I should process each of these tasks, is essentially a topological sorting.
Well, the great one, but I think to complete zero. Hello.
Yeah.
So to complete zero, how many? I mean to say that if it is a work, then what are the things I have to complete if I want to enter into zero?
To enter in this zero, right?
Yeah.
So both 5 and 4 has to be processed.
Yeah,
So
Aditya.
what is happening, right? Here. Hello. Hello.
Yeah, we can hear you. So Kranthi asked me to continue because his internet is not working now. So you guys, I think we're pretty close to 9:50, where we generally end the session. So for this, can you think of any edge cases that your code is not considering? Like,
Yeah. So one thing that, which I should have kind of clarified earlier in the interview was about the detection of cycle, right? So if we do have a cycle, then this particular topological sorting will not work. So I kind of assume that all of this is like an acyclic graph, and there are no cyclics present. So that is one of the edge cases that I think should have discussed earlier, and I kind of missed that one. Apart from that, yeah, I should have also discussed if this was going to be a weighted graph, but looks like this was not having any weights. So I assume that that's one more kind of what I'd like to say, an enhancement that we can later improve on. So these are the two things I'd like to say, Martin, not handled by the current code.
okay, and okay, so cycles. How about what happens when you have like many nodes? Do you think this code will behave well? Like
So
hundreds of nodes, thousands.
yes, so that should not be any problem there. I don't see any issues with respect to the number of nodes or with respect to the scale. Uh, because I'm using something called as a deck here, which is essentially an improvised version in Python for a list. But whenever whatever I append and remove, from this particular list is in O of 1 time complexity. So if I just do something like sources.pop, it will start removing from the right side. But if I'm using pop left, it will remove the first entry that came. So it's like an improvised. So Python doesn't really have something like a queue, which we have it in Java. So this is like a pretty good data structure from the collections module, I believe, and it has given a good practical time complexity of being over 1 times. So with more number of nodes, I think this will work completely fine, Martin.
Okay. Well, I think yeah, I think we reached the end. I don't think Kranthi, do you want to give it a try to give feedback, or you think your internet just won't work? Okay, if you want to, just unmute yourself and jump in. Otherwise, we can continue. So the first question is for you, Aditya. How do you think you did? How do you feel in this interview?
So I think I kind of did good, but with requirement clarification, I did some mistake. I should have asked about the cycles, correct? That was one part, and also about the weighted graph. That is one thing that I missed. And I think there was maybe when I was doing some dry run here, I wanted proper uh, pen and paper. That is something which I was missing, so that it would be easy for me to sketch it. Yeah, overall it was a good question, I guess, Martin. It kind of, but what I also felt is um, I was not able to get this exact output, correct? And it has like a more than one solutions, right? So that is one part. And the main part is about the cycle. That's the thing I missed, I feel.
I see. Okay. Yeah. Anybody from the audience does have any feedback for either Aditya or Kranthi? Again, this part is about both the interviewer and the interviewee.
Yes, Martin.
Yeah, go ahead.
So about Aditya, I have that your dry run is wrong, and also in the figure, in the diagram you have drawn, you said one can also be the part of remove, means it can be also a source node, but it can't be right. It has an incoming edge from 3.
Oh, yeah. Okay.
And many similar like that. But your code
Oh,
is fine. It's working.
yeah. I think like when I was kind of tracing the code flow might be wrong. I think I missed that part because I was writing everything in one line here, and yeah, I correct Naga. Yeah, that's one part I missed it.
Okay, example is wrong, but code is nice. And you are
Yeah,
also explaining while you are coding. It's a very good thing.
thanks Naga.
And also about interviewer, I have one thing like you should have asked the time complexity of the algorithm, like that kind of thing.
I think he asked in the beginning.
Oh, okay. Maybe I didn't pay attention to it.
Huh.
Okay, then that's it from my side.
Yeah, I have one feedback for the interviewer. So I felt like at times, like I think it's due to the internet issue for Kranthi, that initially he was not able to, respond whenever Aditya was coming up with points. Maybe, a yes would have helped. Yeah, that's something I felt like. It could have been a little more interactive, I would say.
Anybody else has? Oh, so I'm actually gonna just share the feedback from Kranthi, and he's saying that you have you were very good in explaining, your thought process. And I guess while he finished typing, I can share mine. Yeah, I mean, I think part of it was I don't think you knew the drop option was there in the beginning.
Yeah.
My guess is that if you knew from the beginning that was available, you would have spent a lot more time there. So
Yeah, true.
so yeah, I don't think that's it's hard to blame that, you know, but on you. But yeah, I would say yeah, I would have spent a little bit more time even with the comments, you know, kind of like having a visual representation and make sure you have like the mental model. But overall, I think it was a good interview. You know, it was a good answer. I like how you added the comments and you kind of updated the state in each line. That's actually very good before you even run it. And the other thing is you didn't use the compiler to find your, you know, some issues. I don't think there were any. So I think that speaks about your, you know, ability to kind of like code very clean from the, you know, under pressure, or, you know, under an interview. So I think that's great. You know, that tidbit that you said about the deck and the collection kind of speaks about how you know the language and know the, you know, the little performance, you know, little things on the language. So I think that's good too. So I think overall, my only, you know, thing that I think you can improve is, yeah, make sure to solve the problem really, really well before any coding, you know, to have it like the dry run is solid, and I think that would, you know, that would help for next interviews.
Okay.
And just from coming back to Kranthi, he's asking, how would you improve, you know, how would you move from your knowledge of Python to get to a 9 or a 10? Like, I think what he's asking to ask you, how would you improve your Python?
Yeah, so Kranthi, to address that, right? So few of the things I'm not so familiar from the Python point of view. One being something called as an asynchronous programming, and the one more is also related to the async frameworks. So I come from a Java background, but because of my work here in my company, I'm using Python, and I've been working with Python for about like 1.5 years. But there are still many things in Python that I'm still not aware of it. There are many libraries and packages which are similar to the built-in Java classes that I'm not aware of it. So I'd like to say that I can write pretty well in Python, but there are few things like async IO or asynchronous programming. Those are the important concepts which I'm still not so confident about.
Okay. Does anybody else have any feedback? And again, it's feedback for both the interviewee and the interviewer.
Hey, this is Vivek. I had some quick feedback items. So
Yeah.
First one is like, I think overall this was a very pleasant interview. I think the topological sort, the question, it looks like Aditya, you are super familiar with it. You kind of knew what needed to be done. So I think there's a lot of familiarity all along, and you demonstrated super strong control and command over the entire process. So I think this is like a classic case of where you know what needs to be done. And now what you're doing is like essentially theatrics, right? You're just playing to the interviewers, like, you know, you're just working this whole thing out in real time. It's like almost like a drama that's being enacted in real time. So very good bunch of pieces here. So a couple of things. Let me just start with the positives. I think you were super articulate. You were helping. You were like, you know, talking through your code. You were very clear. I don't think you kind of like, you know, fumbled or stumbled on any of the, the programming constructs as such. I think the dry run like miss that you had, which Naga caught, is something that that definitely, if you a little bit more care, could have avoided that. But again, I think it's also a function of transcribing, like you're going through different screens and whatnot. So there could be a couple of other mitigating factors. Usually an interviewer would have interjected at that point. I'm saying like, what do you mean it's 2? It should be 1 or whatever. Like, they would have stopped you. And then that would have been like the end of it. But in this particular case, unfortunately, Kranthi was not able to do that as well. So small thing there, but not a big one. The second thing is like code is fairly compact and well written. I think it is like pretty neat. It has all the right pieces in place. You've used the right language constructs, and I think Echo Martin's thing on your understanding or command of the language is showing very well. You're comfortable with the big O calculation. I think you did well overall in all of these things. If at all anything, just as like, feedback, I'd like to give you a few things to think about in general. So number one is more in terms of your communication style as such, right? So see if you want to slow down like a tad bit, like, go to like 90% of the current speed that you have. You were rushing a little, and and here you knew the question, so you probably were like in command and things like that. But that's like, I think going a little slower. Not all interviewers are actually super fast, so they may or may not catch all the nuances and things like that. So some of the niceties that you have, you're demonstrating, you would not impress the interviewer if you're not going slow enough. So just try to like, dock down your speed a little, not by a lot, because obviously you still need to cover. It's just the speed of speaking, not anything else. So that is one. It's a harder thing to fix, but it's worth trying. The second thing is, again, this is, I think Martin mentioned this in a different way, but the way I look at it is that I try to divide the interviewing part into like, 4 distinct phases, and you should do justice in each of the phases. So there is a requirements clarification, requirements gathering, and problem exploration phase. And that is a time where you keep asking questions about like, null values, range checks, will there be cycles or not? All of those questions should be covered as a part of the requirements clarification. And typically that process doesn't last more than 5 minutes, but that's a very important part. And I joined a little late, so I don't know how much of it was done in that particular thing, but I did see a lot of the requirements get clarified later in the conversation. So it did look like you probably like, glossed over the requirements clarification, because and unfortunately, if you know the question already, I've seen that happen a lot. So even if you know the question, even if you're very comfortable with it, spending that adequate amount of time on the requirement clarification will do wonders. The second phase is problem solving, and this is where you're actually solving the problem without writing a single line of code. And this is where you are coming up with the data structure to use and the algorithm to use. But this is where you would whiteboard the solution. This is where you would look at the test cases that you've captured during the requirement clarification, see if your code, your logic will generally work. Like, here is where you're breaking it down into sub problems and things like that. And that part of it, I think I think you did that in conjunction with coding, not as a separate step. And that I think it was fine. It's not negative because you've done it this way, but I think it would be way better if you had done it independently. So that way, problem solving is like a separate step, and then coding is a separate step. So the thing is that some of the requirement clarification also happens during the problem solving, in case like, edge cases, corner conditions, or something you've missed and whatnot, because that way you like, I think there are like, exceptions, or there's special cases that we talk about at times. And then when we do that, you discuss that during the problem solving aspect of it. And then coding would be your, like, you want to leave about somewhere in the vicinity of 15 minutes or so for coding for sure. And then the last step is testing, which is where you explicitly test for a particular test case. You rocked on the testing front. I think you've done a fantastic job of, barring the miss that Naga pointed out earlier, but you had like a very good way of getting through it. Like I'm surprised how you just like missed that particular thing. I mean, it was probably like more of an oversight, or just like a transcription error or something, because you had everything written down. It was very clear, neat, and concise and whatnot. So well done overall. So I think on the whole, this is definitely one of the good interviews I've seen in the recent past, between a bunch of mock interviews here and the other interviews that I've been seeing as well. So great work, Aditya.
Thanks, Vivek. Thanks. So sometimes, even though I knew questions, sometimes I feel when I see the timer, I get kind of scared, and sometimes I make mistakes. Like especially, I'm more comfortable on paper pen and on whiteboard, and that's something which with online I'm still yet to work on. So here I didn't see that draw option literally, and that costed me. So thanks, Vivek, for giving me such a in-depth feedback that will help me. I'll definitely work on that. Thanks a lot, Vivek.
Awesome. And I think for Kranthi, I think a lot of the feedback is going to be mixed because of like buffered based on the poor internet connection. But I think in general, I do expect interviewers to be a lot more hands-on with the interview. Like you need to control the flow of the interview. You need to make sure that you're getting all the data points that you needed and whatnot. So and fortunately or unfortunately, Aditya, you were like a good candidate. You were doing all the right pieces. So had I been the interviewer, I'd have probably been sitting back and listening. The only thing I would do a little differently would have been to challenge you a little more in terms of maybe adding some more things to the complexity of this problem statement. Like usually, I have additional complexifiers for the problem that I can throw on top of it. For topological sort, typically once you have figured out the order in which it needs to be run, I may actually throw in something else, saying, what if I add or remove like the relationships? Or the other one would be that if there is a loop, can you tell me which loops should I cut so that I can find a topological sort, like I can establish a topological sort, or things like that. So those would be like some other problem statements that I'll explore. If you ace my interview, then these are the extra things that I'll be talking about. But I think overall, I don't know if there is a lot. Unfortunately, I don't think I saw Kranthi lead the interview a whole lot because he was like, mostly passive. But probably I would have been passive as well because I think, Aditya, you were a good candidate. So not a whole lot of feedback, but I would try to be a little bit more hands-on as an interviewer, even if the candidate is like, rocking. That's all my feedback.
Thanks, Vivek. That's so detailed. It's always so helpful, not only to, I think, Aditya, but to all of us to, see, understand these perspectives. And so, yeah, I echo Aditya. Thanks for sharing that.
Thanks, Martin.
Yeah. And before we close for tonight, does anybody have other feedback again for anything?
I have a small question.
Go ahead.
I would like to ask that here he has done the testing part. Means it is a very long thing, right? Is it recommended or should we do in a small time?
Testing is a very significant portion of it. Like if your code is flawless, right, then the testing doesn't matter as much. I mean, so a little bit of testing is enough. But if you have a bug in your code and you don't catch it as a part of your testing, then that's going to be a huge problem. So I think what Aditya did is just about right. You can afford to be a little less thorough, but you'll have to be as detailed and whatnot. I mean, I don't think I see a way around it, and I don't think it took a lot of time. He in general, if I were to look at it, you would test as you go. That's one thing that I think I saw Aditya do as well. And then the second thing would be you go through a final dry run of like the entire thing at the end. And typically it shouldn't take any more than 4 or 5 minutes or something for the final dry run. So I definitely would not shortchange that. That's like could potentially make or break because I'm sure we all make silly mistakes as we're coding. You may assume that you wanted to say greater than, but then you want to say greater than equals, but you just wrote greater than, and then you missed that edge case. So testing is the only way you will catch all of those things.
Okay, thanks, Vivek.
Hi, this is Praveen here. Can you hear me?
Yeah.
Go ahead, Praveen.
Yeah. So I have one question here. Aditya knows the question, and I felt he was jumping into the answer even before the interviewer was uh, striving to, say what the question was. So I would say if you already know the question, especially for mock, you should also, one feedback would be to try an unknown questions, like questions which you don't know the answer, which you don't know the solutions, and then see how you will approach that with the same confidence, and how you will tackle those scenarios. And or if you already know the question, you should tell, I already know this. So then there can be some variation of this. Instead of topological sort, you want to do some other kind of sort, or you want to remove duplicates and then do some other, like, or have duplicates in it. And so some kind of variations instead of what you will do. So that's one feedback I want to give, like, or I want to also ask him, how will you solve it if you don't know the answer?
So one thing here is like, I almost guarantee that like 80-90% of the candidates, like, or the good candidates, would know what topological sort is. This is one of like the bread and butter questions. Like it's much the same as a whole bunch of like, it's almost like a fizz buzz to some extent. This is like one of the standard questions that get asked. So I'm not too worried about like, Aditya saying that I know this question or not. But I definitely, I think I called Aditya out on not spending enough time on the requirement clarification portion. Like that first 5 minutes is important, because then you're level setting the question, you're making sure that you're understanding this and whatnot. This is important for coding questions, but it's like super, super important for other types of interviews, like design interviews, like system design and others, where even though you may know what the question is, the nuances and the parameters are a little different. Like the presence or absence of a cycle in this example, like, should I detect a cycle or not, may change the way you're storing a data structure, or the way you're optimizing for code and things like that. So there are some aspects here that will help. That said, there is always like, in an interview, you have, depending on how well prepared you are, you have a good chance that you will get a question that you know, and you will get a question that you don't know. So I'd love for these mock interviews to be able to simulate both, so that we can see how it works in different cases. So it's actually up to the interviewer. If you come in prepared with a topological sort question, chances are that the candidates, at least here, everybody would know what that question is. Whereas if you come in prepared with something a little weird, a little offbeat, pick a lead code question or a Geeks for Geeks question, which is a little obscure, chances are that you may not have seen. I mean, people have solved hundreds of questions, but there are like thousands of questions out there. So there's a probability that you have not seen that question. So that's what I would look at. But again, that being said, the one thing I do recommend is never in an interview, never say that you've seen the question before. That's not the right phrasing to use, because you don't have any advantage of saying that, because what happens at times is like, topological sort. If Aditya had said, yeah, I've seen this question before, I'm going to say, yeah, that's fine. Go ahead and solve it. And you stumble, that's going to be negative for you, right? Because you're already raising expectations for you. So the thing that I normally recommend saying is like, hey, I've solved a similar question before. So that way you're not really lying. I mean, I don't know if the question is the same, but like, yeah, I've solved something in the same line or in the same direction, or I solved something similar, is a better way to essentially give the interviewer an opportunity to switch the question, while not trying to be, you're not trying to be, I mean, you really don't know whether it's the same question that you solved, right? Maybe there are some variations and nuances that are there, and which is
Exactly.
what you want to focus on. So
yeah, it happened to me. I was interviewing with Google, and then they asked me, like, I already know the question. So I said that I already know this question and I solved it in this way. But if you want, I can solve it. But he said, oh, that's so nice of you to say that you know it. So how did you solve it? I said, I solved it using stacks and some way. How can you use some other way to solve the question other than stacks? Or then I actually use a different way to solve the same question.
Yeah, and I think it's a like, yes, I don't want people to fake this thing, saying don't pretend as if you have seen for the question for the first time and stumble your way through and think. Don't do that. That's like a bad idea. As an interviewer, I know where exactly people get stuck and where they go fast. So if your speeds don't match with where people normally get stuck, it's gonna be a bad sign. Don't do that. But at the same time, I would not generally say, hey, this question I know how to solve this, but it's more or less around like I've solved a similar question before, so I know, like, topological sort. Yeah, I've seen it before. Let's talk about the variations and then the specific nuances, just to make sure that I'm solving it completely or something like that. So, but good questions, Prashant.
Just to add to that, I mean, actually it happened to me that actually did say, oh yeah, I've seen that before. And I end up stumbling on the thing that in my mind, I was, I already saw. So that's probably like a nightmarish scenario too. So I guess just something to navigate through. Yeah, anybody has any thoughts, questions, comments? I'll pause the recording now.